Alright, so this video is going to cover this Maze 1 practice quiz. So let's go through this. It says the program below uses a robot in a 5x5 grid. So I'm going to turn on my, let's do this so I can draw in here. So uses a 5x5 grid of squares. The robot is represented as a triangle, which is in the initial bottom left hand corner. So alright, so I've got my grid. Okay, there's 5 there. And okay, so I would expect you guys to kind of draw something similar out. Okay, so your guys in the bottom, the robot is represented as a triangle, which is initially in the bottom left-hand side, square, so it's right there, and it's facing right, so it's pointing towards over here. So what does it do? Repeats this 2 times, so it moves forward, and it rotates left, so now it will be pointing that way. And then it moves forward, and it rotates, so here, then here, and now it's pointing that way. Okay, so that's where our robot ends up here. So we got to figure out which one, after running which of the following code segments would the robot end up in the same place, facing the same direction after running. Okay, so we got to come up with one that does something similar. And so, I apologize. This isn't going to be perfect. 2, 3, 4, 5, but it's what we got, and we'll make it work. Okay, so right here it says move forward. So do this 4 times. So I'm pointed this way. Okay, move forward, rotate left. So I move forward here, rotate left. Now I'm pointing up. So that's 1 turn. Move forward, rotate left. That's 2 turns. Move forward, rotate left. So it'd be down this way. That's 3 turns. Move forward, rotate left. So that's all that this A does. So A is not right. Okay, so let me see if I can do this without deleting the whole table. So A doesn't work. Let's draw another one of those in there and that. So then we got that. So do this 2 times forward. So do forward, then forward, then rotate left. So that would be 1, 2. That's 1 repeat, and then 1, 2, and then rotate left. So your guy's looking like that. So B doesn't work. B is no good. Okay, C, repeat 2 times, and then these 2 times to move forward. So we're right here. So we go 1, 2, then 1, 2. And then we're still facing this way. We're still facing, right here. Okay. But then we've got code that says rotate left. So now I'm pointing up. And then rotate right, or rotate again. So then I'd be pointing that way. And then to do it again, I would be rotate, going down. And then, so it ends up looking like that. So that's incorrect. C, so our answer must be D, but let's prove it, because we proved all the other ones. And again, this is kind of time consuming, but this is how you should be doing your test, writing this stuff out. So move forward twice, so right here, so 1, 2, and then so I repeated that twice. Move forward. Then I rotate left. I do that. This is looking similar, right? Then I move forward 2, 1, 2, and I would rotate left. So same one right here. So your answer is D. Okay. Okay, so I'm gonna clear all this stuff out for my next one. Some of these are hard to get. Alright, so I'm gonna close that. Let's do the next one. Okay, so Kittybot is a programmable robot that obeys the following commands: walk forward, turn left, turn right. So left goes 90 degrees left, right goes 90 degrees right. Walk forward moves forward. The Kittybot is currently positioned in the 4th row and 2nd column of the grid and is facing right on the grid. We want to program Kittybot to reach the bowl of water located in the 1st row and 5th column. Choose which of these code segments accomplishes the goal. Okay, so what do we got here? You know, and if I want to, I can just use this grid, but repeat 3 times. So walk forward, turn left, walk forward, turn right. So do this 3 times. So walk forward, turn left. Now Kitty is facing that way. Walk forward, turn right. It's facing that way. So that's one time. Okay. So walk forward, turn left. Now I'm facing up. Walk forward, turn right. I'm facing that way. And then walk forward, turn left. Facing this way. Walk forward, turn right. Okay, so that gives me. So it looks like A is your answer, just from the first one, but we can kind of test some of this. Okay. So let's see here. Turn left and walk forward, so that would turn left, and then it goes up here, and then it goes turn right and walk forward, so I'm right there. But it only does this 2 times, okay? So turn left and then walk forward. Oops, I get right here and I don't want to get in the water, so that doesn't work. Okay. C, repeat 2 times, walk forward, turn left. So walk forward, turn left. Now I'm up this way. Walk forward, turn right. I'm that way. And then walk forward, turn left. I'm this way. Then walk forward, turn right. So this one is just, it's the same thing as A, except you need to do it 3 times instead of 2, so that doesn't work. And let's see here. 3, repeat 3 times. Walk forward, turn right. So I'm there. Walk forward, turn left. So I'm there. That's 1. So walk forward, turn right. I'm right there. Walk forward, turn left. Right here. Walk forward, turn right. I'm there. Walk forward, turn left. So that gets me up there, wrong corner. So that would be like right there. So that's not right. So your answer is definitely A. Okay. Okay, so now we're on to 3. Which of the following code options can be used to move the robot, the black triangle to the gray square? So let's do this. For A, move forward, turn left, so I'm that way. Move forward, rotate left again. So that's 1. So move forward, rotate, move forward, rotate left would be this way, and then move forward, rotate left would get me back at the original, so that doesn't work. So next one. Rotate left, so I'm pointing this way, then move forward, then rotate right, so now I'm pointing that way, then move forward and rotate right, move forward, rotate left, so now I'm there, and so I do that 4 times, okay? So rotate left, move forward. So that would be like now I'm doing the second time. Move forward, rotate left, move forward, and then rotate right. So this would mean me pointing up here. Then move forward, rotate right, and then move forward, rotate left. So that's 2. And then you guys, this one definitely works, okay? So then I rotate left, so now I'm pointing this way. Then I move forward, rotate right, so now I'm pointing up. Move forward, rotate right. Move forward, rotate left. So that's 3. And then finally rotate left, so I'm pointing that way. And then move forward, rotate right. Move forward, rotate right. And then move forward, rotate left. Okay, so B definitely is our answer. Let's go through the other ones so that, you know, it's always good to test just to make sure, and also because this is just practice, and, you know, me demonstrating is good for you guys. So 3, move forward, rotate right. Move forward, can't do that, so that's no good. And let's see here. Move forward, rotate left, and then move forward, so I'm pointing this way. That's 1 time, and then I do what? Move forward, rotate left, so I'm now going down, and then I move forward, so I end up here, and then move forward, and then so I run into a wall. So the answer is definitely B. Okay. Forward. A Mouseybot is a programmable robot that can be programmed using the following procedures: walk forward, turn left, turn right, facing wall, can charge. Mouseybot is currently positioned inside a grid environment, facing right in the fourth row, first column. His charging station is located in the first row, 4th column. Mouseybot would like to reach the charging station. So it looks like they're giving us some code, or they give us a repeat until can charge, and then we've got to be able to pick what code to throw in there. There are many different ways. Okay, so let's do this. Let's start testing. So for this one, turn left, so he's facing this way, and then move forward 1, turn right, so he's facing that way, move forward 1, so you end up there. Forward 1, rotate left, move forward, then turn right. Okay, what does it say? There are many ways for him to reach the station of the options below, which will require the most repetitions. Okay, so left, forward, right, so that's 1 repetition. Okay, so that'd be from right here, that's 1. Wait. Left, move forward, turn right. Sorry, that's 1. So that's, sorry about that. Here, let me do that again. I want to count how many times, because this one gets there, but I want to count how many times it does it. All right. So turn left, move forward, turn right, move forward. So I'm facing that way. Okay. So that right here, that's 1. Okay. Left, I'm up, move forward. Okay. Right, and then move forward. So that's 2. Turn left, move forward, turn right, move forward. So that's 3. So A is 3 repetitions, okay? All right, so then it says, if it's facing the wall, turn left, which is not. So else forward 3. 1, so 1. So it's not, if it's facing the wall, turn left, else move forward 3. So 1, 2, 3. So that gives us our first one. Okay, so if it's facing left, if it's facing the wall, which it is, turn left. So it's going to go up here. Then it So the way the if else is, it doesn't do the else, it only does one of these. So since it did turn left, now it's got to repeat a third time. So it's not facing the wall now. So 1, 2, 3, and so it gets there. That's 3 repetitions. Okay. C. Let's see here. Turn left, so it's facing here. Then 1, 2, 3, and then for the second repetition, face the wall. Nope, this one doesn't even work. Okay. So let's clean this up a little bit. Okay. And part D, let's look at this one real quick. Walk forward, turn left, so he's facing this way. Walk forward, oops. Turn left, so he's facing that way. Walk forward, turn right, so he's facing that way. So walk forward, turn left, he's facing that way. Walk forward, turn right, so he's facing that way. Walk forward, turn left, so he's facing that way. Walk forward. So that is 1, 2, that's still 3. Okay. And then let's see here. E, if you're facing the wall, turn left, which we're not, so walk forward 1. If it's facing, turn left. Let me erase some of this stuff. So this is the most amount. So this one's going to definitely be the most amount, because what we're not facing the wall, but we just go forward 1. Okay, so now we're facing this way, and then we do another repetition. We're not facing the wall, so then we'll move forward. So that's 1, then 2. Then 3, then we go this way, and then 1, 2, 3. So 1, 2, 3, 4, 5, 6. This one's 6. So your answer is E. Okay. All right. So next up is 5. It says, this is the hardest one on here. It says the program below uses a robot in a grid 5x5. The robot is represented as a triangle, which is initially the bottom left. Bottom left. Okay, let's pull this up so we can draw out our 5x5 grid. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the robot is represented as a triangle, which is initially in the bottom left, facing towards the right. So it's facing that way. Okay. After running the following code segment, how many possible squares could the robot end in? Alright, so this is definitely not the easiest one. So a random number 1 to 4. So x can be 1, x can be 2, x can be 3, and x can be 4. Okay. So it says repeat x times, move forward. So if it's 1 time, it would move here. If it's 2 times, it would move there. If it was 3 times, it would move there. If it was 4 times, it would move there. Okay, so that's this right here, this loop statement. You don't know what x is because it's random, but it could go here, 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 or here. All right. So then we rotate left. So we're if it's 1, we're pointing that way, 2 that way, 3 that way, 4 that way. Then it says y can be, if x is 1, then y can be 1. If x is 2, y can be 1 or 2. If x is 3, y could be 1, 2, or 3. And if x is 4, y could be 1, 2, 3, or 4. Okay, because that's where you have right there. So this is going to depend on which one. So if y is 1, if y is 1, you could have this square. You could end up in this square, okay? If y is, if x is 1, let me think here. Did I do it backwards? I'm trying to think here. If x over... if x could be 1 or 1, so that takes care of this right here, okay? Now we got to do this. X could be 2, so 1, 2, and y could be 1 or 2, so y could be 1 or 2. So all I'm doing now is just doing the different combinations here. If x is 3, 1, 2, 3, and then y could be 1, y could be 2, or y could be 3, and then x, if it's 4, y could be 1, 2, 3, 4. So after running the code segment, how many possible squares could the robot end up in? Well, you just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And your answer is C. This is by far the hardest one so far. And it definitely takes some logical thinking, okay? So that's 5, 6. Let's see here. Okay, the American Standard Code for Information Interchange between, better known as ASCII, uses numerical values to encode characters. The decimal base 10 value 97 represents an A, 98 is a B, 99 is a C. This pattern continues, and lowercase z has 122. Each of the ASCII can be represented as a 7-bit. So ASCII characters represented by this number. Alright, so this is pretty easy. We should be able to figure this stuff out by now. We've done a bunch of these, but I'm going to keep going back to them. So when we do this, I'll write out 1, 1, 0, 1, 1, 1, 0, 1, 2, 3. So this is, you know, if we were to do our, you know, so 1, 2, 4, 8, 16, 32, 64. So it's 64 plus 32 plus 8 plus 4 plus 2. Okay. If we add these up, 8 plus 32 is 40, plus that's 104, 104, 108, 110. It's 110. And so then we write out, it says A is 98, A 98, B 99, C 100, D 101, A, B, C, D, E, F, G, H, I, J. So this is 102, 103, 104, 105, 106, 107. K, L, M, N. So 108, 109, 110. Wait. I screwed something up. 97 is A. So, sorry. That's 97, 98, 99, 100, 101, 102, 103, 4, 5, 6, 7, 8, 9, 110. So your answer is D. Sorry about that. When I did A with 98. Here, I did A with 98 when I should have looked at that. It's 97. I caught myself, but because I looked over and I was like, wait a second, M is not one of the answers. And so, you know, I knew I was one off when I saw that 110 was going to be N. And so, okay, but either way, the process is good, and your answer for 6 is C. Okay. Let's see here. 7, consider the following numbers in 3. Okay, so this is just going to take a little bit of work. So let's write these out. So we want to do ascending left to right. So what I'm going to do is just figure out some of these binary. So I got 1, 1, 0, 0, 1, 0, 0. So 1, 2, 4, 8, 16, 32, 64. So I've got, let's see here, 64 plus 32 plus 4 is what, 96, 100. So that's 100. So this one right here is 100. That means, okay, so left to right. If we were to write out, where's the next one? 1, 0, 0, 0, 1, 0, 1, 1. So that's 1, 2, 4, 8, 16, 32, 64, 28. So 128 plus wait a second, 1, 0, 0, 0, 1. So 128 plus 8 is 136, 37 through 8, 39. So that's 8 plus 2 plus 1, that equals 139. So this one is 139. Okay. So left to right, this is 100, this is 100. Let's check and see what 64 is. So you got 6 times 16 to the first plus 4 times 16 to the 0. So that's what, 4, and then 6 times 16 is let's see here. I gotta get my calculator out just because I want to do this quickly. 6 times 16 equals 96. So 96 plus 4 equals 100. So this is 100. So this is 100, 100, and 100. Let's check FF. FF is, so you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. F. So this is 10, 11, 12, 13, 14, 15. So you got 15 times 16 to the first plus 15 times 16 to the 0. And so this is 255. Okay, so this one is 255. This is 255, and all those on, that's 255. 139, 139. Last one we can convert real quick. Whoops. 8b, that would be what? So this one's right here. 8b is 8 times